This video we shall discuss about the further statistics, October-November 2024, paper 42. Let's take a look at the first question. Number 1. A scientist is investigating the length of a leaf of a certain type of plant. The scientist assumes that the lengths of the leaves of this type of plant are normally distributed. So his assumption is normally distributed. He measured the length of X centimeter of the leaf of a random sample of eggplants. For this type, his results are as the following here. At 5 and 9%, 90% confidence interval for the population mean length of the leaf of this type of plant. Okay, so we are looking for confidence interval. So first of all, we need to total up the X over here. That means we need to find the total for this data. So the total for this data is 30.6. And after that, we need to find the sum of the square as well. So the sum of the square I have calculated earlier. So the answer is 120.52. Then we need to use the unbiased estimations of the population variance. The formula will be 1 over the 7 of the 120.52 minus the 30.6 square divided by 8. Okay, so just use your calculator. You can get this as the 0.49643. Oh, I forgot to find the mean. So the mean is a 30.6 divided by 8. Then you will get this as a 3.825. Okay, so these are the two important values for us in order to find the confidence interval. So for the 90% of the confidence interval, the critical value is 1.895. So the critical value of the Z of 0.95. This one is 1.895. So this will give you the 90% confidence interval for the population mean is equals to the X plus minus a Z 0.95 and square root of S square divided by N. Okay, so I just put in the value 3.825 plus minus of 1.895 square root of the S square 0.49643 divided by 8. Use your calculator, press it, leave the answer in 3 significant figure. Then your interval will be 3.35 to 4.30. Done. This will be the answer for the question number 1. Now moving on, we have question number 2. Variable X has the BGF given by the following functions over here, where the P and Q are constant. Then they're giving you that the mean is 1.1 and we want to find the numerical values of the variance. So the numerical value means over here, it will be decimal. Okay, they didn't mention exact value, so we can just leave our answer as decimal will do. Okay, that is meaning of numerical value. So now we need to find the G prime. So it will be P plus 2QT. Oh, we need to find the we need to find the P and Q first. So we should start from here. We should start from here that the Gx of 1 is a 1. That will give you 1 over 5 plus P plus Q is equal to 1. Then the P plus Q is actually 4 over 5. That is the first equation. Then G prime is a P plus 2QT and EX equals to 1.1. Given This will give you to the G prime of 1 is equal to 1.1. That will give you P plus 2Q is equal to 1.1. Okay. Then this one is your second equation. So just take the second equation minus the first equations, you get a Q equals to the 0.3. That will give you, from the equation 1, the P is equal to 0.8 minus the 0.3, you get 0.5. Okay, so we have found the P and Q. Now we just need to put in the G double prime here. G double prime is actually 2Q. 2Q is a 2 multiplied 0.3 is equal to the 0.6. Then the variance is the G double prime of 1 plus the G prime of 1 minus the G prime of 1. So this one we have found is a 0.6. This one is 1.1 minus a 1.1 square. Okay, so just press the calculator, you get the answer as 0.49. That is how you get the answer for the part A. Now we move on to the part B. The random variable y has a BGF given like this. The random variable z is the sum of independent observations of x and y. Okay, so they give you the gy already. So we just say that z is equal to x plus y. That means your gz is equal to the g of x plus y t. So according to the relationship that we have, the plus over here means actually it means multiplications over here. My gxt just refer to the answer from the at the beginning of the questions is 1/5 plus the pt plus the qt square. But we already found that the pt is the p. We have found that the p is half. Okay, half. And the q is 0.3, 3/10. Multiply this. So what you need to do, just need to expand them carefully at the end. Okay, we try to take the 1/30 out. This one, you make it become 2 plus 5t plus 3t squared. This one you will get 2t plus the t cube. So you get something like this. Then you just need to expand them carefully. At the end, you get this expansion. I just direct summarize for you. So you get 4t plus the 10t square plus the 8t cube plus the 5t power 4 plus the 3t power 5. Okay, so this is the BGF for the Z, just like that. This is a 3. So part B done already. Now we go for part C. Part C is that the probability for Z greater than 2. So this one, it will be the same as a probability for Z equal to the 3, 4, and 5. So all we need to do, just look for the coefficients of 3, the power of 3, 4, and 5 of t. Okay, and take their coefficients. It will be 8/30 plus 5/30, and then plus the 3/30. Press the calculator, you'll get this as the 8 over, direct simplifying 8/15. So this will be the answer for C. Now we want to move for the D. State the most probable value of Z. So the most probable value of Z, it will be the highest probability or the highest frequency, or you can say the highest coefficient of t. So this one is a t square. the highest frequency is 10 over, is 10 over 30, 10 over 30. So what is the variable that give you 10 over 30? The answer is 2, power 2. So it's a Z is equal to 2. So just say that the PZ equal to 2 will give you the coefficient value of 10 over 30, and it will be equals to 1 over 3. Okay, see, this one is the greatest probability. So therefore, your Z is a 2. This one is a greatest probability. So this will be the answer for the number 2D. Let's move on to the number 3. Minute is recorded for each pot. The results are summarized in the following table. And Rosie suggests that the number of seeds of that germinate follows the binomial distributions of n is a 5, p is unknown. Okay, so we want to show that p is equal to 0.42. So for these questions, what we can do is we need to find out the mean first for this. So this is the x, this is the frequency, right? So what you need to do is to find the sum of the fx. So the sum of the fx is actually 315. Just take this multiply, this multiply, this multiply, this multiply, this multiply, and this multiply. The total, you get 315. And the sum of the f is 150. So the mean is 315 over 150. Okay, then in binomial distributions, the mean is NP is equal to 315 over 150. So therefore your P is, your N over here is 5. So it's a 5P. So therefore your P, just press a calculator, you will get the answer as 2.1, 0.42, sorry. Okay, so this is how you get the answer for the P. Okay, so now we move on. Carry out a goodness of fit test at 10% significant level to test whether the distributions of the binomial, where the n is a 5, p is a 0.42, is a good fit for the data. Okay. So what you need to do now is, first of all, we need to build the table for the expected frequency. This is the observed frequency. We want to build the expected frequency. So over here, we need to rebuild again the table. So let me just draw the table. This is the X, this is the OI, this is the EI. And the X start from 0, 1, 2, 3, 4, and then 5. So over here, you will get this as a 12, 40, 43, 35, 16, and 4. So these are the given observed frequency. We want to find the expected frequency ourselves. So over here, generally the EI is actually equals to 150 multiplied by the PX equals I. By the I is 0, 1 until 5. So we will suggest the formulas over here. The general formula, it will be 5CI and the B power of I and Q power of 5 minus I. So generally it will be like this. So all the value here, you just need to, for this value, you just put E0, then you get 150 multiplied by 5C0, 0.42 power 0, and 0.58 power of 5. Okay, and then you press the calculator, you will get the answer as 9.846. Okay, so 9.846. Okay, so this is the expected frequency. Now there's no need for you to list out all the formula. Okay, so over here I will suggest to write down the general formula for the expected frequency. So just need to show this formula. Okay, then need to show this formula. Then need to mention that your I is starting from 0, 1 until 5. So the rest of the table over here, the value over here, they will follow this formula. Okay, so just suggest the general formula over here will do. Okay, and the rest, you just press the calculator directly. So to save time, I have calculated the value earlier. So I just write down. This one is 35.647. This one is 51.627. This one is 37. Okay. Wait, let me calculate again. I is a 3, so 0.42 power of 3 multiplied by 0.58 square multiplied by 5C3 multiply 150. So you get 37.384. 37.384. Then this one is the $13.536. And the last one is 1.960. Okay, so you can see that this part is less than 5. So less than 5, we need to combine the table. So over here, I will combine the table. So I need to draw the table one more time. So this is X, this is the OI, this is the EI. So this is a 0, 1, 2, 3, and then greater or equal to 4. So when we combine them, this one is not affected, just copy down only. This is a 20. So this one, just copy down as well, 9.46, 35.647, 51.627, 37.384. And the last one is just combine these two together. So if you combine these two together, you get 15.496. Okay, so this is the table that we need to use it to do the hypothesis test. Now we are ready to do the hypothesis test. And now hypothesis test just say that the binomial distributions of the 5 and 0.42 is a good fit for the data. Then versus the alternative hypothesis is that this is not a good fit. For the data. Okay, so this is the hypothesis that we have. Then now we continue. We are looking for the degree of freedom. So the degree of freedom, it will be how many column here? 1, 2, 3, 4, 5. 5 column. You minus a 1 and minus a 1. Okay, so you get a 3. Minus a 1 because the constraint is that the sum of the O must equal to the sum of the E. Minus another 1 is because the B is estimated. Okay, so therefore you have the minus 2 constraint. Okay, so your degree of freedom will be a 3. So now just use your formula booklet to find the critical value or the tabular value. The critical value will be the degree of freedom is 3, and your significant level, your confidence level is 0.9. So just use the formula booklet. You can see that this will be 6.251. Okay, now we want to calculate the test statistics. So the test statistics, the chi-square, the formula will be the sigma of the OI minus the EI square divided by the EI. So for the 5 values that we have over here, just take the OI minus the EI square divided by EI. So the first value, it will be 0.4712. 4 decimal places, 0.5316. This one is 1.4416. Then plus with 0.1520. And this one, it will be 1.309. And sum it up, total up, you'll get 3.91, correct to 3 significant figure. So now we just compare the test statistics. You compare with the critical value. Okay, so who is bigger? The test statistics is less than the critical value. Okay, so over here, which means that the chi-square is actually less than the test statistics. The test statistics is less than the critical value. So over here, we do not reject H now. Okay, we just mentioned that we do not reject H now. So conclusion. There is insufficient evidence to suggest that binomial distributions of n is a 5, p is a 0.42 is not a good fit for the data. Okay, done. This will be the answer for the question number 3. And now moving on, we have question number 4. This has the PDF function f given by the following piecewise functions over here. Part A, they want you to find the CDF of the x. So what we need to do is we just need to integrate the PDF that is given. So from the domain of 2 to 5, we just need to integrate the functions over here is 1 over 21 x minus 1 square dx. So I will just direct integrate. I will get this one as 1 over 63 x minus 1 power 3. Okay, and then plus you integrate from 2 to x. From 2 to x. So if you put the x inside, you will get x minus that. If you put 2 inside, then you will get 1 cube. Yes, 1 cube. So at the end, your answer will be 1 over 63 x minus 1 cube minus a 1 over 63. Then therefore, your CDF will be 0 and 1. For 0 is for the x that is less than 2. 1 is for the x greater than 5. And if it's between 2 to 5, if it's between 2 to 5, that will be the function that we have found just now. So it will be 1 over 63 x minus 1 cube minus a 1 over 63. So done. This will be the answer for the part A. Now we move on. We want to find the random variable y is defined by this. This is the random variable defined by x minus 1 power 4. Find the PDF of the y. Find the PDF of the y. So what we can do is that we just direct start from the definitions. The gy is actually by less than equals to y. Then the y is given as x minus 1 power 4. Okay, so what you can do is that you just need to make it become x minus 1, make it like this, y power 1 over 4 plus 1. Okay, so this will be your function, and this will be the same as the fx. Okay, it will be the same as the fy over 1 over 4 plus 1, because we know that the fx is actually the bx less than equals to x. Okay, so this is what we are having. Then the substitute them inside. Substitute this value inside here, the piecewise function, the CDF that we found just now. Change all the x become y power 1 over 4 plus 1. So this will become 0, 1, 1 over 63. This one will be the y power 1 over 4 power 3 minus a 1 over 63. Then your x is y power 1 over 4 plus 1 less than 2. 2 between y power 1 over 4 plus 1. And this one is the y power 1 over 4 plus 1 greater than 5. Okay. So not enough space for me, but anyhow, never mind. Let me just finish this one first. So this one, if you simplify them, at the end you get this one, your y will be less than 1. This one, your y will be greater than 256. So the y over here is between 1 to 256. If you solve the inequality here, then you will get this inequality. Then this one simplify, you will get 1 over 63, y power 3 over 4 minus 1. So this will be the CDF, but they want PDF. So if they want PDF, your GY is actually the G prime Y. So it will be differentiate them, differentiate this whole thing. Okay, so I direct differentiate it. Then you will get this one as 1 over 84 y power negative 1 over 4 for the y between 1 to 256 and 0 for otherwise. Okay, so this will be the answer for the question number 4B. Then after that, move on. Question number 5. No, this one is number 4C. Still have 4C. Find the median of y. So to find the median of y means we want to look for this. Then we'll give you the answer as a half. Okay, so just need to put into this function. Okay, so it will be 1 over 64, 1 over 63, m power 3 over 4 minus a 1 is equal to half. So what you need to do now is just to solve it. Okay, so if you solve this, then you will get this m is equals to the 63 over 2 plus 1 power of 4 over 3. Okay, so just press a calculator, you get 103.6 7. Okay, but the question didn't mention anything about the value of median. So we just need to give the answer in 3 significant value. So it will be 104. Just mention that this one is 3 significant figure. So this will be the answer for the C. And now we move on to the D. We want to find the mean, the expected value of Y. Okay. So we want to find the expected value of Y. Then this one, it will be EY is actually integrate from 1 until 256. Okay. The function that we have multiplied by Y. So if you multiply by Y, then you will get this one as 1 over 84, Y power 3 over 4. Integrate it, you will get 1 over 147, Y power 7 over 4 from 1 until 256. Replace them inside. 256 power of 7 over 4 minus a 1. Press a calculator, it will be 111.449. Or if you give the answer in 3 significant figure, then it will be 111. So this will be the answer for the question number 4D. Moving on, we have question number 5. The bottles we choose. Dave is investigating the volumes of juice in bottles. He chooses a random sample of 35 bottles filled by machine X and the random sample of 60 bottles filled by machine Y. The volumes of juice X and Y respectively measured in suitable units are summarized by the following data here. Dave claims that the mean volume of juice in bottles filled by machine Y is greater than the mean volume of juice in bottles filled by machine X. Test at alpha % significant level such that there is a sufficient evidence to support Dave's claim. Okay, so in order to support Dave's claim, that means you have to reject H now. So over here, what we need to do is we need to calculate, before we do the hypothesis, we need to calculate the mean of the bar X and the bar Y. So the bar X is 30.8 divided by 35. Then this one, it will be 62.4 divided by 60. Then just press the calculator. You will get this one as a 0.88. This one you will get 1.04. Then after that, you want to calculate the unbiased estimations of the population variance of X. It will be 1 over 34. 29.0 minus the 30.8 square divided by 35. Press the calculator, then you will get the answer 0.055. 765, 0.55, 0.055,765. Then similarly for the unbiased populations, unbiased estimations of the population variance of Y, it will be 76.8 minus the 62.4 square divided by 60. Press the calculator, you will get 0.201763. So after this, you need to find the combined variance. My variance is S square. It will be Sx square over Nx plus the Sy square over the Ny. So it will be 0.055765 divided by 35 plus the 0.201763 divided by 60. And press the calculator. You will get this one as 0.00495660. Okay, so with all this information ready, now we can do the hypothesis test. Hypothesis test is that we start from the mu y is equal to the mu x. Okay, then versus the alternative hypothesis is that they mentioned that is greater. Okay, so that means the mu y is greater than the mu x. Okay, so you can write in another way. It's like the mu y minus the mu x is equal to 0. Then you can write the mu y minus the mu x is greater than 0. But over here, I didn't write like this. I just leave it as this form. Okay, so this one is actually a right tail test. This is a right tail test. So now we want to go for the critical value. Oh, this one we don't have critical value because we do not know the alpha. We do not know the significant level. We cannot find the alpha. So this time we need to find the test statistics first. So the test statistics will be the bar y minus bar x. Okay, so you'll be having bar y minus the bar x minus the mu y minus the mu x divided by the square root of the combined variance s square. Okay, this is only s square. There's no need for me to write a big square root here. So the bar y minus bar x is actually then 1.04 minus 0.88. Then minus divided by square root of 0.0049560. So if you press a calculator, you will get this as positive 2.2728. Okay. So we need to reject H now because from the questions, we need to reject H now. So in order to reject H now, we just need to, you can see that this is a right tail test. This is the Z alpha, and this is the region. Okay. We do not know this value, but we know that the test statistics must fall into here in order to reject H now. So we just try that to reject H now. Okay. Then your test statistics, this test statistics is a Z. Okay, this test statistics is a Z. I forgot to write Z. So the Z must be at this region. The test statistics must be at this region. So the test statistics must be greater than the Z alpha, greater or equal, greater or equal. Okay, so it will be the Z alpha is less than equals to the 2.2728. Okay. Okay. So what we can do is just need to write the value, which is 1 minus the phi of the 2.2728. This will be equals to the 1 minus the 0.9885. This will be equals to alpha. This one will be equals to the 0.0115. Okay, so if you make it become 100%, you get 1.15%. Okay, so therefore your alpha is actually 1.15%. Okay, so this will be the answer for the question number 5. Move on. We have question number 6. Of the times taken by students to run one lap of a running track. The population's median time is taken is 51.0 seconds. After a month of intensive training, a random sample of 22 new students run one lap of the track, giving times in seconds as follows. So we have 22 data over here. It is claimed that the intensive training has led to a decrease in the median time taken to run one lap of the track. Carry out a Wilcoxon sign rank test at 5% significant level to test whether there is sufficient evidence to support the claim. So over here, to save time, I have built the table vertically, and I write down the data over here, 11 data over here, and another 11 data over here, because the 22 data is too long for me to fit in the space given vertically. So I split them, become 22, 22. Okay, so over here, I need to calculate the sign rank test. So to get the sign rank test, I need to minus them with the median value 51.0. So we need to fill up all this thing here. Okay, we need to fill up all this thing here. Oops, sorry. So this one, we just need to minus it. So this is going to take us a little bit of time. So if you minus this, you get positive 0.3. This one is 1.0, 2.4, negative 1.8, negative 1.7, 0.1, 1.2, negative 3.8, 2.0, negative 3.5. Negative 2.5, sorry. Then negative 1.6, negative 0.7, negative 0.2, 0.6, negative 1.9, 1.3, 0. Negative 3.1, negative 2.1, negative 0.4, and positive 0.9. So we need to calculate the P is representing positive, Q is representing negative rank. So we need to count them from the smallest to the largest. Okay, so regarding the, we just need to split them. If it's a positive, we put it under P. If it's a negative, we put it under Q. Okay, so we will start from here. This is the 1. Okay, and 2 will be here. And then 3 will be here. And then 4 will be here. 5 will be here. 6, 7, 8, 10, 11, 12, 13, 15, 16 is here. 17 is here. 18, 19, 20, 21, 22. Okay, so we have found the ranking over here, positive rank and negative rank. So we need to find the total here. The total for the positive rank is 102. The total for the negative rank is 152, 151, sorry. Okay, so from here we can find the test statistics. Test statistics is that the T is equals to the minimum of the 102 and 151. That will be 102. Okay, so we built the hypothesis, null hypothesis and alternative hypothesis. The null hypothesis telling you that there is a decrease in the median. Okay, they want to check. The claim is that there is a decrease in the median time. So the null hypothesis is supposed to be there is no decrease of the median time. The median time still remain as 51.0 second, and versus there's a decrease less than 51.0 second. Okay, so this is the left tail. Okay, so now we need to find the critical value. Okay, so over here I don't plan to use the I plan to use the p-value test. Okay, I plan to use p-value test. So my alpha is a 5%, okay, which is a 0.05. Then I go and find the mean, okay, by using this formula. So why? Because the data here is 22. So the M is 22. The N the is actually M. This one is 22. It's already over 20. Yeah. Okay. So it's considered a large number. So over here, just find the mean, round up. So this one, it will be 22, 23 over 4. So you will get this as 126.5. Then after that, you find the variance. The formula will be given as this one, it will be n plus 1 and then 2n plus 1 over the 24. So this one will be 22, 23, and 45 divided by 26. This will give you 948.75. Okay, so we are looking for the p-value test. So I go and calculate the p-value. Okay, so probability x less than or equal to 102. Okay, the reason we put 102 is because our mean is 126. Then the test statistic is 102. The test statistic is 102. So you go to the left hand side. Okay, go to the left hand side. So just make it become CC. It will be 102.5. This is the continuity corrections. Then change it to Z. This will be 102.5 minus the mean 126.5 divided by square root of the variance 948.75. Press a calculator and you get this answer as the PZ less than the negative 0.778. This will be the 1 minus the 5 of the 0.779 is the same as 1 minus the 0.7821. So your answer will be 0.2179. Okay, so this is your p-value. Your p-value is actually greater than your alpha, okay, because of 0.2179 is actually greater than the p-value. The p-value is 0.5. That means the p-value greater than the alpha. Okay, so for this case, you just need to say that is do not reject H now. Then your conclusion is there is insufficient evidence to support that the mu y is less than the mu x. The mu y less than the mu x. Oh, no, not mu y minus mu x, sorry. It's about median, okay? Mu y minus mu x was the previous questions. This is the m less than 51.0. Okay, support that the m less than 51.0. Okay, done. So this will be the answer for the question number 6. Okay, so this will be the answer. So now no more questions over here. So I'll stop the video. I'll see you next time. Bye bye.